Good morning, friends, and welcome to another episode. In today's episode, we'll be looking at how to prepare standard solutions. Alright, so I believe we can start now. First, we need to understand what standard solution is. So let's see if we can define what a standard solution is. So a standard solution is a solution whose concentration is known. So any solution whose concentration is known is a standard solution. So for example, if I tell you there is a solution that is having concentration of let's say 2 molar, of maybe volume of let's say 1000 cm cube, this is a standard solution. It is a standard solution because you know the concentration of this solution. So that's what standard solutions are. Now, and we are going to look at how to prepare some of these standard solutions. However, before we move on to the preparation of these standard solutions, it's very important we look at some of the tools that can help us prepare them. So we'll start with some of them. So let's look at the first tool. Now the first tool is the spatula. Spatula, as you can see from the diagram, is like a spoon. And you know what spoons are used for? Spoons are simply used for scooping things. And that's exactly what the spatula is used for. It will be used for scooping chemicals from their containers wherever you want to use them. So if you want to scoop any chemical, you'd use the spatula. You do not expect to use your hand to do that because most of these chemicals are very dangerous and very harmful. So you'd use the spatula for that one. The next item apparatus you'd use is the weighing balance. And weighing balance, we all know what weighing balances are used for weighing. So you need to measure a specific mass of an item. You would use the weighing balance for that. And normally, in the laboratory, especially when it comes to preparation of solutions, we measure the masses of chemicals to be able to prepare these solutions because it's usually the mass you can practically measure. Most of substances are there, but there is no tool that can help you to really measure the mole of a substance. So it's usually easier when you use the weighing balance to rather measure the mass and just come up with your calculations or get your, let's say, mole equivalents of those masses to prepare your solutions. I'm sure when we start solving problems, you understand this better. So, no, the weighing balance is used for measuring the masses of chemicals in the laboratory. Now, the bigger normally is a container usually made of glass, and you normally pour chemicals into the beaker. And you normally be mixing chemicals in the beaker. So, for example, you put the chemical here and maybe add another chemical to this, and that's it. You mix them together in the beaker. So the beaker is just a glass container into which you'll be putting chemicals. Sometimes you'll be mixing your chemicals in them. So that's what beakers. Now let's move on to the next item. For the next item, we'll be using the wash bottle. So as you can see, it's a water bottle. Actually, it's a water bottle. So the water bottle, it will contain water. So you have water in this bottle. The water will be in this bottle. And if you want the water, you want to use this water, all you do is to squeeze it. Once you squeeze it, the water will flow out of this place and you can use that water for whatever you want to use it. So remember, wash bottles are water bottles. They contain usually distilled water because in the laboratory you might want to use pure water, distilled water for your mixing of chemicals and all of that. And usually when it comes to preparation of standard solutions, cold water you're going to use. And that's what a quart bottle will do in. Next item will be a stirring rod. So as you can see, this is a stirring rod. It's just a rod, and it's usually made of glass. And we use it for stirring, as the name implies. We use it to stir chemicals. So, for example, you have a solution, a mixture of, let's say, sodium chloride and water. You want the sodium chloride to dissolve faster. You can use the stirring rod to stir so that it will dissolve faster. Simple as that. So that's what stirring rods are used for. Let's move on to another item. So here we have volumetric flasks. Volumetric flasks are simply flasks and they are calibrated. They have sizes. So as you can see, they come in different sizes. The first one might be, let's say, 1000 cm cube volumetric flasks. This one might be, let's say, 500 cm cube volumetric flask. Then this one might be, let's say, 800 cm cube volumetric flasks. So these flasks come in various sizes, and we choose them depending on the volume of maybe solution you want to prepare. For example, you want to prepare a solution with volume of 1000 cm cube, then it will be appropriate for you to choose a 1000 cm cube volumetric flask. Let's say you want to prepare a solution with volume 500 cm cube. What it means that it will be appropriate for you to choose this volumetric flask, because it's 500 cm cube volumetric. You want to prepare a solution with volume of, let's say, 800 cm cube, then you go for this volumetric flask. So the point is this: we use volumetric flasks to usually prepare solutions or at specific volumes. So the volume of the solution you want to prepare determines the kind of volumetric flask you are going to choose. I'm sure when we start our practicals, you will understand this better. Let's move on to another item. So a funnel. You all know what funnels are. So this is a funnel. And normally this is what we'll be using the funnel for in this case. So let's say you have a volumetric flask like this, and you want to transfer the liquid in the beaker into the funnel. So into the flask, volumetric flask. All you do is just to put the funnel here. So that's the funnel. It's being placed here. Then you would pour your content from the beaker into. So that content from the beaker will be poured through the funnel here so that eventually it will get into the volumetric. So that's what the funnel will be used for, so that none of the content of the beaker would spill out. So it's basically to make it easier for you to pour the contents of the beaker into the volumetric flask without you pouring or spilling any of the chemical. So it's as simple as that. So these are some of the apparatus we're going to use in our experiment or in the preparation of some standard solutions, and we're going to be using them very soon. So let's look at an example. Now we've been asked to prepare um, this let me just volume of solution of this concentration, 0.5 molar. In fact, 0.5 molar is the same as 0.5 gram, sorry, the same as 0.5 mole per dm cube. You need to remember that. Same thing. So molar. Now, and we've been asked to prepare this solution um, with this volume, 1000 cm cube. Then again, we've been given an important information, that's the molar mass of the sodium hydroxide solution we are yet to prepare. That information has also been given to us. So what we're going to do is this: I'm going to repeat all of these data given to us on another page. Then we'll use the data to solve the problem. So on another page, we have the concentration given to us, it is 5 molar. The molar mass given to us, it is 40 grams per mole. And the volume of solution we will be preparing is 1000 cm cube. It has been given to us. Now, the first step in preparing this solution is to determine the mass of the sodium hydroxide used in the preparation. Remember, and in determining the mass of the sodium hydroxide, all we need to do is to use the information given to us to do that calculation. We solved a lot of problems in previous videos on how to determine mass of substances when molar mass and mole and all of those things are given. I think this is the point where we will be applying those skills we learned. So let's see if we can simply do that. Now, the first thing is this: the volume here. You realize that the volume given to us here is 1000 cm3. Remember, in a previous video, we said that volumes in calculations, okay, more concept calculations should never be in cm cube, but they should rather be in dm cube. So that's the first thing we need to remember. We need to change or convert from cm cube to dm cube. How do we do that? We do that by just dividing by 1000. So our volume, if we want to convert from this 1000 cm cube to dm cube, all we need to do is to divide by 1000. And when we do that, that will give us what? 1 dm cube. So that's the volume we are going to be using. 1 dm cube. So the volume is no more 1000 cm cube. It is now going to be 1 dm cube. This is the volume we are going to use. So now we know the volume we're going to use. Now, first thing we need to do is to determine the mole of the NaOH. Then from the mole, we can determine the mass. How do we determine the mole? Remember, there is a relationship between mole, volume, and concentration, and that relationship is the C equals to the mole over the volume. I believe you've not forgotten this relationship. So from this relationship, we can simply do simple change of subjects. And when you do simple change of subjects, you are going to get the mole to be equal to the concentration times the volume. So that's how we are going to determine the mole. The mole will be gotten by multiplying the concentration by the volume. The concentration has been given to us. The volume we know. So we can use this to determine the number of moles of sodium hydroxide here that we are going to use. So how do we do that? So the mole will be giving us the concentration, which is 0.5, multiplied by the 1 dm cube volume. When we do this calculation, what are we going to get? That will give us mole of 0.5 mole. So that's the mole we are going to use, 0.5 mole. Now we know the mole. How do we use the mole to determine the mass of the sodium hydroxide, which we'll be measuring eventually? Remember, there is another relationship also between mole, molar mass, and mass. And that relationship is simply number of mole equals to mass over molar mass. I believe you remember this relationship as well. So from here, we can also do simple change of subject. And the mass will be equals to what? The mole times the molar mass. So this is what is going to help us determine the mass of the sodium hydroxide. So mass is mole times molar mass. We know from the question given to us the mole. We calculated that ourselves and it was 0.5 mole. The molar mass, we know it has been given to us and it is 40 grams per mole. What it means that the mass will be 0.5, which is the mole, times the molar mass, which is what? 40 grams per mole. When you do the calculation, our mass will be what? 20 grams. So now, this is the mass we are going to measure. So we're going to measure this mass and use it to prepare our solution. So in the next stage, that's what we're going to do. So in the next stage, we are going to weigh that mass with the weighing scale. So remember, the mass we're going to weigh is what? 20 what? Grams. This is the mass we're going to weigh. And we're going to use our weighing scale. So let's say this is our weighing scale. We are going to use it to weigh the item. So that's what we're going to use to weigh. When we weigh, to make sure that we have the right quantity of sodium hydroxide for our solution preparation. We weighed 20 grams. After we weighed the 20 grams, what do we do with the 20 grams? What we do, the next step is to put that measured mass into a beaker. So this is a beaker. We are going to put into this beaker 20 grams of the sodium hydroxide, solid sodium hydroxide into this beaker. Remember, we weighed it, so 20 grams of the solid sodium hydroxide, we will put it into this beaker. So that's the next thing we're going to do. Once we are done with that, what do we do next? Let's move on to the next step. We move on to the next. So that's the 20 grams of sodium hydroxide solid in the beaker. All we need to do, that's when the bottle of water, the bottled water, that's what we call that, comes in. So this bottled water comes in. Remember, it contains water. We pour the water here, it's distilled water, remember. So this wash bottle comes in, contains distilled water. So we pour small, just some amount, appropriate amount of the water into this beaker. And we are doing that so we can dissolve the sodium hydroxide. We pour it into it, and remember, it is distilled water. So after we do that, what do we do next? We move on to the next stage. So this is the water mixed with the sodium hydroxide solid. This is the point where our stirring rod comes in. So we bring our stirring rod and we stir so that the sodium hydroxide will mix uniformly with the distilled water so that we can have a uniform or homogeneous solution. So we now stir with our stirring rod. What do we do next? We finish stirring, we move on to the next stage. It's time to select an appropriate volumetric flask. So this time, what kind of a volumetric flask do we select? Remember, the question said that we are preparing 1,000 cm³ solution. So what it means is that we have to prepare this, we have to select 1,000 cm³ volumetric flask. Remember that we select volumetric flask based on the volume of the solution you are preparing. So that's how come we will prepare this kind of volumetric flask. So we are done with getting this volumetric flask. We selected 1,000 cm³ volumetric flask. What do we do next? So let's quickly move on to the next stage. So now we are going to pour the solution from the beaker. Remember, we formed the solution in the beaker from distilled water and sodium hydroxide, the 20 grams of sodium hydroxide. So this is the part where we are going to pour that solution into this volumetric flask. So let's say this is our beaker containing our sodium hydroxide. Let me just make it easier. So we pour it, we pour this content from the beaker into this container like this. So we pour it here. So we pour it into the volumetric flask. So we pour everything into the volumetric flask. So after we do that, we're going to have an empty beaker. Now this empty beaker, remember, it will contain some of the sodium hydroxide. So what we need to do is to use the wash bottle to rinse it. We need to rinse it with some more water. Alright, it's very important you do that. Rinse it with some more water. When you rinse it with some more water to make sure that all of the sodium hydroxide has been washed, you come back and you pour it again into the volumetric flask. As simple as that. And please, once you rinse it, even the stirring rod would also have to be rinsed because you might have some of the sodium hydroxide on the stirring rod. So you rinse everything, then you pour them into the volumetric flask. And the reason you are doing that is to ensure that all of the sodium hydroxide that you collected, the 20 grams of sodium hydroxide, is poured into the volumetric flask. So that's why you do that. And the next stage is to do what? Now you put that content, the content of the beaker into the volumetric flask. Remember, we are preparing 1,000 cm³ solution. So what it means that we have to now top the content. When you poured it, it was somewhere here. So we need to now top it up with water to the brim where the 1000 cm³ mark is. So we need to add some more water. We add some more water so we get to the 1000 cm³ mark. So we know that we have that volume of 1000 cm³. So now we've been able to top it up with distilled water. Please remember it's distilled water you'd have to top it up. So we have topped it up with distilled water. Now after you are done that, what do you do next? Because you've topped it up, the solution is not uniformly mixed. So this is the point where you would have to cover it with, let's say, a stopper. Use a stopper to cover this. Okay, when you use a stopper to cover it, then you shake it so that the solution will be uniformly mixed. At this point, you've been able to prepare your 1000 cm³ solution, which is also 0.5 molar. So we've been able to prepare this solution. It's as simple as that. So that's how you prepare a 0.5 molar solution, which is 1000 cm³. Let's look at another example, then we'll be done with this. So next example. In this example, we have to prepare 500 cm³ of 0.6 molar sodium nitrate solution. We've been given the sodium nitrate uh, molar mass, so we are going to use this to prepare another solution. So the next stage, let's just get the information. So with the information needed to prepare the solution, we have this concentration is here, we have the volume is here, we have the molar mass is here. Remember, the constant volume given to us is cm³. So this would have to be converted to dm³. What do? We need to divide this by 1000 to get it converted. When you do that, you get 0.5 dm³. So that's the volume you are going to use for your preparation, not 500 cm³, but rather 1000 dm³. Just remember that. So at this point, what do we do next? We need to first calculate the mole of the substance you're going to prepare. So the mole, when we would use this formula, concentration equals to the mole over volume. So from here, do simple change of subject, and what would happen? The mole will become what? Concentration times volume. From here, you can calculate the mole. The concentration given to us in the question is 0.6. Volume given to us is times 0.5 dm³. When you multiply the two, you are going to get mole of 0.3. So that's the mole we are going to use. So let me just circle this. This is the number of moles of the chemical we're going to use. Of course, you cannot measure mole directly in the laboratory. We must convert it to its mass equivalent. So how do we do that? There is a relationship between mass, mole, and molar mass. So mole equals to mass over molar mass. So from here, do simple change of subject, and the mass will become what? The mole times the molar mass. So this is what you'll be using. Mass equals to mole times molar mass. So now how do we determine the mass? Mass will be, the mole is 0.3. Molar mass is what? The molar mass is times 85 gram per mole. So you multiply the two, and what are you going to get? When you multiply 0.3 by the 85, what will you get? You get 25.5 grams. So what it means that we are going to measure this 25.5 grams using our scale. So this is what we are going to do. So when you measure our 25.5 grams using our scale, what do? We then transfer it into our beaker. When you put it into the beaker, we add distilled water to it to dissolve it using our stirring rod. When you are done dissolving it completely, what do? You pour it into the volumetric flask, the appropriate volumetric flask. Here in this case, the volumetric flask will be choosing to be a 500 cm³ volumetric flask, because remember, the volume of the solution we are preparing is 500 cm³. So we need to choose 500 cm cube volumetric flask. So we choose that, we pour the solution that we have prepared from the beaker through a funnel into the 500 cm cube volumetric flask. We rinse the content of the stirring rod as well as the beaker. Then we pour all of those rinsed content into the volumetric flask. Once we are done, we then top the volumetric flask up with distilled water to the 500 centimeter cube mark. We now cover it with a stopper, then we shake it. We shake it well so that the mixture would uniformly mix together. At this point, we'll be able to form our 0.6 molar 500 cm cube concentration of what? Sodium nitrate. It's as simple as that. And I believe this will bring us to the end of today's video. Please, if you do not understand anything, just go back to the video and rewatch. And I believe this will make sense when you do that. And please subscribe to the channel if you've not done that. And please share the video with your friends who are struggling with integrated science. We'll meet again in the next video. Bye.